Welcome back to our continued conversation on properties of logarithms. In today's notes, we're going to talk about the other two properties, okay? Expanding logarithms and the change of base formula for logarithms. So, expanding is almost identical to what we did yesterday. Uses exactly the same properties. So now we're using it to split a logarithm up, write it as large as possible, instead of condensing it down. So what that means when you're expanding means every power should be brought down as a coefficient, and every product or quotient should be separated as addition or subtraction. All right? So, here, the first thing that I notice, the first thing is this division right here. Okay? So that division means this should be split up like that. Then, this multiplication, that multiplication should be written as addition. So expanding is literally doing what its name implies. I'm writing it out bigger, okay? I'm separating it out into many different terms, okay? So let's look at this next one here. So, I need to erase part of this so I have space. I see that division. So I'm going to rewrite this as log base 9 of x to the 4 minus log base 9 of 81. I see this power up top, so I'm going to bring that power down as a multiplier. Okay, remember this is exactly the opposite of yesterday, so that power should be brought down, okay, as the rule implies. Now, notice this term right here, okay? This I want to draw your attention to. Log base 9 of 81. So we can actually evaluate that with pretty ease. So 9 to what power gives you 81? Well, 9 to the second power. So in these, sometimes you are going to be expected to do that mid-problem, okay? I kept them pretty basic, so my hope is you'll see it relatively easily, but do make sure you're catching those times when they can actually simplify further, okay? So, this next one, the first thing I notice is multiplication. So I'm going to split that up. So log base 3 of 9 plus log base 3 of x to the 5th. Now again, I notice here, 3 to what power gives me 9? That's going to be 2. So mid-problem, sometimes I'm going to have to be able to evaluate a logarithm. And now I see this exponent. So I do want to make sure I remember to bring that exponent down as a power. Just like that. All right, now this next one, I see division. Okay, and division, we know, equates to subtraction. So log base 5, 250 minus log base 5 of 37. Now, this one is a challenge problem, okay, because most of you I'd probably expect would stop here, okay? But I do want to show you a trick that would allow you to actually keep going here, okay? So, this 250 is the same as 125 times 2. Okay, now you might be wondering, why am I doing that? Okay, why have I split it up like that? Well, by switching that to multiplication, notice now I can break off that 2. Now you still might be wondering, what in the world drove me to do this? Well, 125. 5 to what power gives me 125? And what you'll notice is 5 to the third gives me 125. So by recognizing that that power of 5 went into 250, I knew to split that up. Now, don't worry, I'm not going to give you anything that complex. I just merely wanted to expose you to that idea that some of these you can have a hidden thing you have to break out. Okay, here because a power of 5 was embedded in that 250, I knew that I could keep breaking it down. Okay, test-wise, you're not going to have anything that complex, but it's something that is worth showing you because I could show up on the ECT or something like that. All right, this one, I see a bunch of multiplication. So let's break that multiplication down into addition to separate it out. All right, so again, like I've been telling you, sometimes mid-problem, you're going to see something that can break down. 4 to what power gives me 16? Well, 4 to the second power gives me 16. That square root, is really a 1/2 exponent. Okay? And the reason that I want to write it as a 1/2 exponent is because now, remember, whenever we have a power, we need to bring that power down. So that would be my final answer because I don't want a power up there. All right, so these are what that basic property looks like of expanding, okay? Learning how to expand those logarithms. Now, oh, I'm sorry, that's not what I wanted to do. All right, so to lead into our next concept, let's review just a little bit more of that simplification process, again, from 7-3. So, to evaluate this logarithm, 6 to what power gives me 216? This one, you can play around with a calculator a little bit. 216 is 6 to the third power, so that would evaluate to a 3. Here, 100 to, 100 to what power gives me 10? Well, if I need to rewrite this, 10 is the square root of 100. Square rooting is a 1/2 power. So that log would evaluate to 1/2. 1/4 to what power would give me 16? Okay, well, the first thing that I notice is 16 is 4 squared. The other observation I notice is to make it match that fraction, it's going to need a negative exponent to move that 4 down. So remember, those are the two skills. Remembering 1/2 is a square root, and that a negative is how you flip fractions around. Now, there are situations where you're not going to be able to write it nicely, okay? So what happens when that case arises? What happens when you can't use that nice little transformation? Well, there actually is a very slick, simple way to do it, okay? That is the change of base formula, okay? What the change of base formula says is if I take the log of 27 divided by the log of 81, that'll calculate that original logarithm for me. Now you may be wondering, you just wrote it as two separate logs. How's that going to help you? Well, the way it's going to help me is I can actually type that into the calculator now. Because remember, this is really log base 10, base 10. I just don't have to write that. And that's something my calculator can actually do. That button right there can actually do that for me. So in rewriting it in this form, I've turned it into something that I can calculate. Okay? So this one turned out to be 1.3 repeating, which as a fraction is going to give me 4/3. So that's where this comes in handy, is I can actually calculate any logarithm, evaluate any logarithm using my calculator. Okay, so here, log base 36 divided by log base 5. Now most of the time this is going to happen. Most of the time you're going to get some nasty number. And at the college level, which is what we're going to adopt, what their expectation is 4 decimal places. Okay? That's kind of the general rule of thumb for logs, 4 decimals. So this would be 2.2266. That would be my answer. And here, log 18 divided by log base 4. And again, to 4 decimals, 2.0850. All right, so this feature of the calculator gives us the capability of evaluating any log, even if we can't do it nicely like the ones that we've been doing. Okay, so I think that's probably the easiest of the properties because literally all you're doing is typing it into the calculator, which I love. Most kids had no issues with that section. So let's do one last problem. Let's wrap up with a word problem, and then we'll be done with notes for today. So the pH of a substance is equal to negative log of the concentration of hydrogen ions. The concentration for ammonia is 10 to the negative 11. For vinegar is 6.3 times 10 to the negative third. What is the difference in pH levels of ammonia and vinegar? All right, so the difference. Difference means subtraction, okay? So the difference between ammonia, well, ammonia, they said is 10 to the negative 11. The difference between ammonia and vinegar, so minus, but then we have a negative here. And vinegar is 6.3 times 10 to the negative 3 gives me that. All right, well, this double negative here turns into addition. So now I have something I can legitimately just type into my calculator. Okay, so this one is mainly the setup that you need, but now let's just type it into the calculator. So I have negative log of 10 to the negative 11 plus log of 6.3 times 10 to the negative 3. So I can legitimately just type all of that into my calculator, and the difference in their pHs is 0.87993. 8.7993. Okay, keeping with that 4 decimal rule, but that's going to be the difference in their pHs, which is quite a big difference in terms of pH. Okay, because the pH scale, we've already talked about, only spans 14. So huge difference, being almost 9 apart. All right, so thank you so much for joining me for this. So in your summary, I think the biggest thing here is to know the differences between expanding and condensing. Okay, reiterate what the differences are, what the steps are between them to make sure that you can help keep them straight. All right, so again, thank you for joining me. Come back ready to do your practice work.